Hello, and welcome to G Fun Facts Online. Have you ever watched a robot in a movie and thought, how does it know not to crush that flower? Or maybe you've seen a real-world robotic arm and wondered why it moves so. Well, robotically. The secret isn't just in the programming or the cameras. The next great leap in robotics isn't about seeing, it's about feeling. Today, we're diving into the incredible world of electronic skin, a technology straight out of science fiction that's giving machines the human sense of touch. Think about it. Your own skin is an incredible organ. It tells you if your coffee is too hot, how much pressure to use when picking up an egg, and helps you find your light switch in the dark. It's a constant stream of rich, sensory information. Now imagine a robot trying to operate in our world without that. Traditional robots often rely on pre-programmed force. This means they might accidentally crush that delicate egg or fail to get a secure grip on a heavy tool. For robots to truly and safely work alongside us, they need to graduate from just looking at the world to actually feeling it. And that's where electronic skin, or e-skin, comes in. So how do you build skin for a robot? It starts with flexible, stretchable materials that can be wrapped around a robot's hand or body, just like our own skin. But the real magic is what's embedded inside, a symphony of tiny sensors. There are pressure sensors, often made of conductive nanowires, that detect the amount of force being applied. This is what lets a robotic hand hold that egg without breaking it. Then you have temperature sensors, like microscopic thermometers, allowing a robot to know if a surface is hot or cold, which is pretty crucial for safety. And finally, strain sensors detect stretching and bending, giving the robot a sense of its own body position, kind of like our own proprioception. Recently, scientists have even developed multimodal materials where a single sensor can react to different kinds of touch, bringing us even closer to the amazing complexity of human skin. Now, this is where things get truly mind-blowing. What happens when a robot gets a cut or a scratch? With traditional parts, it's broken. But what if its skin could heal itself? Researchers are developing e-skin with incredible self-healing capabilities. By using special polymers that can automatically reform broken chemical bonds, this skin can literally mend itself after being damaged. We're not talking about waiting days for a repair. Some of the latest versions can recover over 80% of their functionality in just 10 seconds. This is a game changer for creating durable, long-lasting robots that can handle the real world. And the innovations don't stop there. Scientists have now created the world's first 3D electronic skin. By mimicking the layered structure of human skin, this new design can sense pressure, shear force, and strain all at once, giving the robot a much richer, more nuanced sense of touch. But wait, how do you power all this? Batteries are bulky and need recharging. The solution? Self-powered e-skin. By embedding tiny nanogenerators that convert the energy from movement into electricity, these e-skins can power themselves. This is a massive step towards creating truly autonomous and energy-efficient robots. This all sounds incredibly cool, but what does it mean for us? The applications are huge. In manufacturing, robots with e-skin can handle delicate components with a new level of precision. In search and rescue missions, they can navigate dangerous and unpredictable rubble by feeling their way through. For amputees, this technology promises a new era for prosthetics. Imagine a prosthetic limb that can feel the warmth of a loved one's hand or the texture of a piece of fruit. Researchers have already successfully allowed a volunteer to control a prosthetic arm using a circuit transferred to their own skin. And in healthcare, e-skin can be used as wearable monitors that track our vital signs, or give surgical robots a superhuman level of sensitivity for delicate operations. From self-healing materials to self-powering sensors, electronic skin is fundamentally changing what's possible for machines. It's not about making robots more human in a creepy way. It's about creating a future where machines can integrate more seamlessly, more helpfully, and more safely into our lives. The future, it turns out, is tactile. Thanks for tuning in to G Fun Facts Online. Join us next time for another dive into the amazing world of science and technology.